Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick at the end of the problem where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 125 to the power of x is equal to 3,125. Now 125, this is the same thing as 5 times 5 times 5, which is the same thing as 5 to the power of 3. And 3,125, this is the same thing as 5 times 5 times 5 times 5 times 5, which is the same thing as 5 to the power of 5. So now I can simply replace these values into my equation here. So now I have 5 to the power of 3 to the power of x is equal to 5 to the power of 5. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 5 to the power of 3 to the power of x, this is going to equal 5 to the power of 3x, which is equal to 5 to the power of 5. Now if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 3x is equal to 5. So now if I divide both sides by 3, I get x is equal to 5 over 3. So this is my answer. Alright, so I have 4 to the power of x plus 2 to the power of x is equal to 30. Now 4 here, this is the same thing as 2 squared. So now I have 2 squared to the power of x plus 2 to the power of x is equal to 30. Now if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So 2 to the power of 2 to the power of x, it's going to go 2 to the power of 2x plus 2 to the power of x, which is equal to 30. Now I'm going to rewrite 2 to the power of 2x as 2 to the power of x to the power of 2. So I have this plus 2 to the power of x, which is equal to 30. Now I'm going to let I'm going to let the variable y equal 2 to the power of x. So now I have y squared plus y is equal to 30. Now if I subtract 30 on both sides, these two cancel out, and I'm left with y squared plus y minus 30 is equal to 0. Now to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to 1, and c is equal to negative 30. So I have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 30 all over 2 times 1. So this simplifies to negative 1 plus or minus the square root of 1 plus 120 all over 2. Now 1 plus 120, that's equal to the square root of 121 over 2, and the square root of 121 is 11. So I have negative 1 plus or minus 11 over 2. So this gives me two expressions. I have negative 1 plus 11 over 2, and I have negative 1 minus 11 over 2. Negative 1 plus 11 over 2, this is equal to 10 over 2, which is equal to 5. Negative 1 minus 11 over 2, this can equal negative 12 over 2, which is equal to negative 6. So my two values are 5 and negative 6. So y is equal to 5 and y is equal to negative 6. Now remember how 2 to the power of x is equal to y. So this gives us two equations. 2 to the power of x equals 5 and 2 to the power of x equals negative 6. Well, 2 to the power of x equals negative 6, this is wrong because you can't take the power of a positive number and make it negative. So I'm simply left with 2 to the power of x equals 5, and to solve this I can take log on both sides. Then I can move my exponent here, so I have x times log 2 is equal to log 5. And now if I divide both sides by log 2, I get x is equal to log 5 over log 2. So I have 9 to the power of 2x is equal to 27 to the power of x minus 2. Now, the simplest way to solve this problem is to actually make both of these bases the same. So right now, we have a base of 9 and we have a base of 27. And we want to make these two bases the same. Well, 9 and 27, these two are both powers of 3. So 9, this is equal to 3 squared, and 27, this is equal to 3 cubed, or 3 to the power of 3. So now if I substitute these two values in for 9 and 27, then this will have our problem be solved, and both our bases will be 3. So now if I do this, I get 3 to the power of 2 to the power of 2x is equal to 3 to the power of 3 to the power of x minus 2. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of 2x, that's going to equal 3 to the power of 2 times 2x. This is equal to 3 to the power of 3 times x minus 2. 2 times 2x is 4x, so I have 3 to the power of 4x is equal to 3 to the power of 3x minus 2. I can simply distribute the 3. 3 times x is 3x, and 3 times negative 2 is negative 6. So now I have 3 to the power of 4x is equal to 3 to the power of 3x minus 6. Now if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 4x is equal to 3x minus 6. Now all I have to do to solve this is subtract 3x on both sides. So then these two cancel out, and I'm left with x is equal to negative 6. So this is my answer. Alright, so I have 2 to the power of x squared over 4 to the power of x is equal to 16. Now the first thing I'm going to do is I'm going to change 4 to the power of x, because 4, this is the same thing as 2 squared. So now if I substitute in 2 squared for 4, I get 2 to the power of x squared over 2 to the power of 2 to the power of x is equal to 16. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2x. Now this is equal to 16. Now as you can see, both our bases for both these terms are 2. So I'm actually going to try and convert 16 into a term that has a base of 2. So in other words, 2 to the power of what equals 16? Well, 2 to the power of 1, this is equal to 2. 2 to the power of 2, this is equal to 4. 2 to the power of 3, this is equal to 8. 2 to the power of 4, this is double of 8, which is 16. So meaning I'm going to change 16 to 2 to the power of 4. So now all our terms are in bases of 2. So now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x squared over 2 to the power of 2x is going to equal 2 to the power of x squared minus 2x, which is equal to 2 to the power of 4. Now if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x squared minus 2x is equal to 4. So now I can subtract 4 on both sides, and I get x squared minus 2x minus 4 is equal to 0. So now to solve this problem, I can simply use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 2, and c is equal to negative 4. So now I have x is equal to negative of negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, times c, which is negative 4. Now I have this all over 2a, so 2 times 1. Now I have x is equal to negative 2 is positive 2, plus or minus the square root of negative 2 squared is positive 4, minus 4 times 1 is 4, negative 4 times negative 4 is positive 16, all over 2 times 1 is 2. Now I have x is equal to 2 plus or minus the square root of 20 over 2. The square root of 20, this is the same thing as 10 times 2. 10 is the same thing as 5 times 2. So now I have x is equal to 2 plus or minus 2 root 5 over 2. So now if I divide 2, I get x is equal to 1 plus or minus, these two cancel out, so the square root of 5. So this is my answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 5,555 squared minus 4,444 squared. And if we have something in the form a squared minus b squared, this can actually be written as a plus b times a minus b. So in this case, 5,555 would be A, and 4,444 would be B. So now all we have to do is simply plug these values in for A and B. So this means that 5,555 squared minus 4,444 squared is equal to 5,555 plus 4,444 times 5,555 minus 4,444. So now 5,555 plus 4,444, that is simply 9,999. So we have this times 5,555 minus 4,444 is 1,111. Now 9,999 is the same thing as 10,000 minus 1. So now we have 10,000 minus 1 times 1,111. And now, using the distributive property, we can distribute the 1,111 to both terms. So now 1,111 times 10,000 is simply 1111 with 4 zeros. So 1, 2, 3, 4. Minus 1,111 times 1 is just 1,111. So now we have this problem, a huge number minus 1,111, and we could simply do this on paper. We're not going to waste your time by doing that. The answer to this is simply 11,108,889. So this is our answer.